In this video, we're going to talk about 8.1 in our book, area between two curves. We've done a little bit of this before, but we're going to get into it a lot deeper now. We know the area of the triangle shown on the left there from geometry is 1/2 base times height. And since our base is 2 and our height is 8, that's going to give us an area of 8. Now, let's try to work on some calculus skills that will help us down the road when we do more complex problems. So we talked earlier about drawing a representative rectangle and then imagining creating a Riemann sum and then turning that Riemann sum into a definite integral. So as we're going to see, how we draw the rectangle is important. So first, let's imagine we're going to draw some vertical rectangles, something like this. So we will say our delta area, the area of that rectangle, is going to be base times height. We're going to imagine that base is going to be a delta x, and the height is going to be the value of the function at that particular value of x. So we need a function here. So we can see that this is a straight line, and its y-intercept is 8, and our slope is going to be down 8, right 2 is a -4. So this is going to be y equals 8 minus 4x. So we'll say that it's going to be just, say, f of x. But then we'll define that further and say that our f of x, that's going to be our height, is going to be 8 minus 4x times delta x. So that's the description of the area of that one triangle. We'll imagine that we add up n of them and then take the limit as n goes to infinity. And so we're going to get this integral. And the limits of our integral, are going to be 0 to 2. And it's going to be 8 minus 4x. And the delta x becomes a dx. We know how to do this. It's going to be 8x. That's going to be 4 times x squared over 2 will be a minus 2x squared. And we're going to go from 0 to 2. So the 8 times 2 minus the 2 times 2 squared and minus zeros is going to be 16 minus 2 times 2 is 4 times another 2 is 8. And we get that same thing. That's good news. Now let's imagine we're going to draw our rectangles horizontally. So we're going to imagine we're going to do something like this and slice them that way. So our delta area is again going to be base times height. But notice this time, that base, or I guess our base is going to be this distance. Our height is going to be a delta y. So that makes all the difference in the world. So that means we are going to end up integrating with respect to y, which means we need our base in terms of x. So that distance right here would just be, or if we want to think of it here, that distance is the x coordinate of that point, but we have our function given in terms of y. So we will rewrite this with x in terms of y. So I'm going to add the 4x, subtract the y, and then divide by 4 is going to become 2 minus 1/4 y. That's going to be that horizontal distance, our base. So that's going to be then 2 minus 1/4 y times our delta y. So then our area, now it's going to become an integral as we sum these all up, but now we're going to sum from y values that go from 0 up to 8. So that makes our limit now be 0 to 8. And we're going to integrate the 2 minus 1/4 y, and that'll become a dy. So that's going to be 2x minus, the integral of y is 1/2 y squared times the 1/4 is going to be 1/8 y to the second, going from 0 to 8. So that's going to be 2 times 8 minus 1/8 times 8 squared, and then minus the 0. So 2 times 8 is 16, and we can cancel one of those 8's, and that's going to be minus 8. And so you can see we get the same result. Okay. Now, sometimes, these we're going to be able to slice our areas here, our shapes, either using vertical rectangles or using horizontal rectangles, and we have to be able to do it both ways. Now, sometimes either way that you draw the rectangle will work and doesn't make any difference at all. Other times one way may work better, or maybe only one way will actually work. So in this case, if we try to draw our rectangles going horizontally, the problem there, I don't know if you can see it, is when we go to get our base of that rectangle, it's going to be this, the x-coordinate here of this curve minus, well, that's the same curve. So we're trying to take the same curve at two different points and subtract them, and that just isn't going to work. So what that means is we aren't going to do horizontal rectangles. Instead, we're going to do vertical rectangles. So we will then try to describe what's going to happen to that rectangle. So the area of one of those rectangles is going to be its base times height. You can see the base is this distance here, which is a delta x, and the height is again going to be the curve minus 0. So it's going to be that 4x rather, minus x squared times our delta x. So our area, now we got to figure out where it's going to intersect. You can tell from the graph, but you can also see that you could factor out an x, and you can see that it will be equal to 0 at 0 and x, or 0 and 4 rather. So we're going to go from 0 to 4, and we're going to take 4x minus x squared dx. So that's going to be 4 times 1/2 x squared is 2x squared minus 1/3 x cubed, and we're going to go from 0 to 4. 4 squared is 16. 16 times 2 is 32. Minus, we're going to get 4 to the third is 64 cubed, yuck. And then minus, and those are all going to be zeros. So I would say let's make this a mixed number. That might actually be a little easier. So I'm going to say 3 goes into 64, 21 and 1/3 times. So 21 from the 32 is 11, but then we have to subtract one more 1/3. So we're going to get 10 and 2/3. Okay, now here we are back to a triangle again, but let's see if we can do this one using horizontal rectangles so we can get that practice. So we're going to imagine there, and our delta area is again going to be it's just base times height. And we can see that our height is going to be a delta y, which means we need to get our base in terms of y. So we need an equation for this line. So this line we can see goes through the origin, and it's going to rise 3 and run 1, 2, 3, 4, 5, 6. So that's going to be 3, 6, or 1/2. So that's y equals 1/2 x. Now what we want for this rectangle is we want to go the right side minus the left side. Now let me get a different color here. The right side is all the way over here. That's going to be 6. And the left side, this distance to here, is going to be the x-coordinate of that point right there that's on the curve. So we want to take our equation and write x in terms of y. So that means x is equal to 2y. So our base is going to be the right, which is the 6, minus the left, which is going to be that x coordinate, but which we are going to write in terms of y as 2y. So that's going to be our base. So we're going to get a 6 minus 2y. So our area then is going to become an integral, and we are, oops, I bumped that with my left hand and turned it off. So our integral, we're going to be integrating with respect to y, so we need my pen to work first of all. So we're going to need to get y limits, so those are going to go from 0 to 3 on the y, and our integral is going to be our 6 minus 2y dy. So that's going to be 6y minus y squared going from 0 to 3. So that's be 6 times 3 minus the 3 squared. So we're going to get 9. See how that works? Okay, now we're going to start getting a little more complicated. We need to put in an xy axis, and we want to find an equation for a circle of radius 5. And then once we get that circle of radius 5, we're going to try to find the area of that circle. So I'm going to say then find the area. So since we want an equation of a circle, it's a lot easier to come up with an equation of a circle centered at the origin. So hopefully we can see that if this is a circle centered at the origin, that's going to be x squared plus y squared is equal to the radius squared 25. So if we draw a rectangle, so I'm going to imagine we're going to take this rectangle, and its delta area is going to be a base times height. We can see the way we've drawn that rectangle, the base is going to be a delta x, and the height is going to be the top curve minus the bottom curve. The y coordinate of the point on this curve minus the y coordinate of the point on that curve. But our circle, which we said is x squared plus y squared equals 25, that's not written as a function, so we're going to have to solve for y. So we can subtract that x squared, and the y is going to be positive or negative, square root of 25 minus x squared. So the top curve is going to be the positive square root of 25 minus x squared, and the bottom curve is going to be the negative square root of 25 minus x squared. So our rectangle, which we are trying to get this as its height, is going to be that top curve, the square root of 25 minus x squared, minus the bottom curve, the negative square root of 25 minus x squared, which, as you can see, is going to be 2 square root of 25 minus x squared delta x. Okay, so we are going to then get our area is going to be the integral, and we can go from negative 5 to 5, or if we want to use the symmetry, we could say we can go from 0 to 5 and multiply that by 2. Call that the square root of 25 minus x squared, and the delta x is going to become dx, and then we can pull that 2 outside, so our area is going to become 4 times the integral from 0 to 5 of the square root of 25 minus x squared dx. And then we're going to have to go, this is not an integral that we can do, so we're going to have to do this on our calculator. I'm sure that's a bummer for you. So remember, we're going to go math 9. We can actually do it like this. We can go 4 and then times that math 9. Remember, you're going to put 0 as the lower limit, 5 as the upper limit, square root of 25 minus x squared, and then put the dx in. And when you do that, we should get 78.5398, which is 540 for our area. Okay, let's see what else we can do. So without a calculator, can we find the area enclosed by y equals 2 minus x squared, which we can see in green, and y equals negative x, which we can see in the blue. So we can imagine our rectangles. I would go with vertical rectangles. Our delta area is going to be base times height. Our base is, again, going to be a delta x if we're drawing vertical rectangles. The height is going to be the y-coordinate of this green curve minus the y-coordinate of that blue curve at that same value of x. So that's going to be our top curve, which is the 2 minus x squared, minus the bottom curve, which is a negative x. So our area is going to be, looks like a 2 minus x squared plus x dx, and we better figure out what those limits are. So to find these values, it looks like we can see them on our graph, but we can solve that conclusively by setting them equal to each other. And I would add, I like my x squareds to be positive when we factor. We can do our box and diamond, or if you can see it, maybe guess and check, and see that they're going to be 2 and negative 1, which looks like it agrees with what our graph is. So we'll go from negative 1 to 2. Okay, and then I'll leave it there. You can do that from there, and either do it by hand or use your graphing calculator, either way. And I think at the end of the day, we're going to get that that's going to be 4.5. Okay, let's scroll up here, and now we're going to use our calculator skills to try to graph this thing. So you can put the first function in as y1 and the second one as y2 and see what your graph looks like. So when you do, you should get something that looks like this. We have our cosine curve there in blue and our parabola in the red. And we're going to try to find the area enclosed by those two curves. So if we look at, say, a rectangle, a representative rectangle, our delta area is going to be a base times height. The base is going to again be a delta x, and our height is going to be the y value of the blue curve. That's 2 cosine x minus the y value on the red curve. That's going to be x squared minus 2x. Now is where we need to find our points of intersection. So we need to find these values right here. So we're going to, on our calculator, and where we have graphed these, let's go to second trace, so the calculate menu, down to the intersection, and we want to go enter, enter, move the cursor over to the left one, and we can then hit enter, and I'm looking at negative 0.788. So I'm going to write down 3 decimal places, but then I'm going to go second mode to the home screen and go store alpha A and plug it in there. And then we're going to go back to the graphing menu, and we're going to repeat this process. So second calculate down to option 5, hit enter twice to the guess, and move our cursor closer to that second one, hit enter, and I'm going to get 1.341. So I'm going to go second mode again, store that as alpha B, and then we're going to go to our calculator, but before we do that, let's write that the area is going to be this integral from A to B of, and we're going to say, I'm going to even name this, that way I don't have to, I've got these in my calculator as y1 and y2, so I'm going to call them f and g, and then we want to take the cosine curve minus the parabola dx. So showing these things that we have found these points and this is going to be our integral, then we can do our math 9 and go from alpha A up to alpha B, and then we can do our y1, so variables, enter y1 minus the variables, right arrow, whoops, okay, enter, then down to y2, hit enter, and right arrow to the x, and I'm getting 2.987. 2.987. Okay? Now here's a really interesting one, because we can do this 3 different ways. Let's find the area in quadrant 1, so that means we're between the x and y axis there in the upper right hand corner, bounded above by the square root of x and below by the x-axis and then the line y equals x minus 2. So we're talking about this region bounded by square root of x and in quadrant 1 and then over here. So we can do this 3 different ways. Now the first one's kind of tricky. If we try doing this with vertical rectangles, so here's our method 1, then our delta area is going to be a base times height, but you can see that our height is going to be different for part of the interval than it is for the second part. So I'm going to say our first delta area is going to be, its base is going to be delta x, and its height is just going to be the yellow curve minus the white curve, but the x-axis is just y equals 0, so that's just going to be the square root of x. Now the second delta area in this region over here, we can see that our delta area is going to be base times height. Our base is again a delta x, but now the height is going to be that top curve, square root of x, minus the bottom curve, which is our x minus 2. So we're going to get for our area, the boundaries, we can kind of see that here, that x minus 2 intersects the x-axis rather, when x equals 2, and you can kind of confirm that when x is 2, y is 0. So we're going to go 0 to 2, and our integral is going to be the square root of x dx. Then we're going to add to that. Now we're going to go from 2 to where these 2 curves intersect. It kind of looks like that's going to be at 4. We can confirm that because the square root of 4 is 2, and 4 minus 2 is also 2. So that makes that point there for 2. And for us, that means we're going to integrate from the x value of 2 to the x value of 4. Now we're going to have a top curve of square root of x, and if we distribute that minus sign, that's going to be minus x plus 2 dx, and I'm going to leave it to you to do that. And I don't know if I've done that already. Yeah, it's going to be, if you want to check that either on your calculator or by hand, it's going to be 10/3. Now let's do this doing a second method. So second method, let's do our rectangles horizontally. So now we're going to draw them this way. Not very well drawn. Gonna have to really use your imagination. So our delta area here is again going to be a base times a height. Now we can see the height here is going to be that delta y. Now, the base is going to be this length right here, which is always going to be the right curve minus the left curve. But you can see for our rectangles, because remember we're only worried about quadrant 1, so our rectangles are always going to have a right curve, that's the line, and a left curve, that's going to be the yellow square root of x curve. So we're going to go right minus left. But because we have that delta y, that means we need to have everything inside here has to be in terms of y. So our right curve, that was the y equals x minus 2, we're going to have to add the 2 to the other side and call that y plus 2. And the left curve, our square root of x, we're going to have to solve for x, and that's going to be a y squared. We're going to have to use y limits here, and we saw earlier that that y coordinate for where the square root of x intersects x minus 2 is a y value of 2, and because we are in quadrant 1, we're going to go from 0 to 2. Those are the y limits, and our top curve minus the bottom curve, and that's going to be a dy in place of the delta y. And I'll let you work that out, but you'll find it's going to give you the same thing. Now, the third method is really kind of creative. So this is really an outside the box kind of thing. But the idea is if you look at this, you can see that we can find the area we're looking at if we take the area between the square root of x curve and the x-axis and then just subtract off that triangle, just using geometry for the triangle, not the calculus. So we have, if we are going to make our rectangles, and they're going to remember just go from the square root of x to the x-axis all the way through, then our delta area, our base times height of that, the base is going to be a delta x, and the height is always square root of x. So our area is going to be the integral from 0 to 4 of the square root of x dx minus the 1/2 base times height, and we can see that the base and the height of that triangle is 2 and 2. Kind of cool? So there are 3 very different ways of correctly getting to the area in the first quadrant bounded by the square root of x curve on top, the x-axis, and y equals x minus 2 on the bottom. Very good.